Hello, today is our last lesson for 3.4, 3.4c, solving equations with variables on both sides. Again, our first two slides are going to be a little bit of a review, and then when we get to the back side, we will have some new situations that we have not come across yet. So first, let's just review solving multi-step equations. We need to get all of the letters on the same side, all of our variables. This is really a negative 1a, so I'm going to move the one that is the least over to where there are more. So negative 1 is smaller. I'm going to move that. The opposite of subtracting 1a would be adding 1a. And then those eliminate, and we have 7. And then on this side we have a negative 8. Don't forget that piece. 14 plus 1a is 15a. And then we need to get the a by itself. So get rid of adding and subtracting first. Get rid of our 8. Reminder that we are undoing our order of operations. We're really going in reverse to undo or find a. So we have 15a equal to now 15. And then last, the opposite of multiply is divide. So we're dividing by 15 on both sides. 15 over 15 is just 1a or a, and same thing here, it's just 1. Let's take a look on the other side. If you want, you can draw a box to multiply or distribute. I'm going to just multiply using multiplication. 5 times 2 is 10x. Since it's multiplied, again, 5 times a negative 7 is negative 35. And then we have letters on both sides. I'm going to move the smaller one between 6x and 10x. 6 is smaller. It'll keep everything positive if we move that one. If I subtract 6x, those eliminate. 10 minus 6 is now 4x minus 35 equal to 13. Now we want this letter all by itself, so get rid of adding and subtracting first. Add 35. So we have 4x equal to now 48. And then last, opposite of multiply is divide, the inverse. 4 goes into 8 2 times, and 4 goes into 40 10 times, so we have 12. Or use a calculator for that one if you're not sure. So that was a little bit of a review of multi-step equations. Same thing here, but a little bit of application to some geometry. It says find the perimeter of the triangle. The sides of the triangle are equal in length. We call this an equilateral triangle then. So if this side is the same length as this side, that means they are equal to each other. So I'm just going to write them out. 9x minus 3 is really equal to 4x plus 7. So we can figure out what is x. So I'm going to move my smaller x's. I'm going to subtract 4x on both sides. So those will eliminate, and we'll have 9 minus 4 is 5x minus 3. I almost put plus. Whoopsies. Minus 3 equal to 7. Then get rid of adding and subtracting. I'm going to add 3. We're undoing our order of operations. 7 plus 3 is 10. And then divide by 5 on both sides to get rid of that multiplication. 10 divided by 5 is 2. It did ask us for a different question, though. They didn't ask us to find x. It said find the perimeter of the triangle. So if we plug that back in, it doesn't matter which one you plug it into because we know the sides are all the same length. I'm going to use this one here. It says 4 times x, which is 2, and then plus 7. Well, 4 times 2 is 8. 8 plus 7 is 15. So all the sides are 15. 15 plus 15 plus 15 will give us 45. So that would be the answer they would be looking for. They ask us for the same thing on this one. Find the perimeter of the rectangle. We already know this side's 10 and this side's 10. Of rectangles, we know these two sides are equal to each other, so we're going to set 7x minus 15 equal to 2x, and we're going to solve that. So I would normally want to move the 2 to the left side, but since nothing would be there, that's fine. You can put equal to 0, but it'll just be more steps. So I'm just going to move the other number. So we have negative 15 equal to, there's more negatives, negative 5x. And then the opposite of multiplying is dividing. We're dividing by that whole number, negative 5. Those eliminate. 2 negatives when you divide make a positive. 15 divided by 5 is 3. Again, that's not our answer though. They asked us for the perimeter of the rectangle. So if we know x is 3, 2 times 3 right here is 6. The same thing would happen here if I plugged in a 3. 7 times 3 is 21. 21 minus 15 is also 6. So our perimeter is 10 plus 10, which is 20, plus 6, 26, plus 6 more should give us 32. So our perimeter is 32, and they've used the m, which stands for meters. On the back side now, we have 3 possibilities for solutions. We could solve our equation and get one answer, one solution. Oops, come on. Oh, go away. One solution, which would be like x equals 2, or something like that. You solve it and you get x equal to a number, y equal to a number, whatever. We could solve it and get no solution. Meaning you could have solved it and gotten like 4 equal to 2, which 4 is never going to equal 2. It's not possible. So it would be no solution. Or our third solution, if we get the same number, like 3 equal to 3, we call this answer infinitely many solutions. Or you could call it all real numbers. All real numbers. The symbol for all real numbers is a double-lined R. So either one of those would be a good solution. I would normally pick all real numbers because they're telling you no matter what you plug in for x, both sides are going to be equal to each other. I could plug in a 1 and they'd be equal. I could plug in a 2 and they'd be equal. So let's solve a couple and see what we get for solutions. We want all of our letters on the same side. It doesn't matter which 14x you move. I'm going to subtract 14x. 14 minus 14 is 0x. There are none. Don't even write x because there aren't any to write. So all we have left is negative 8 equal to 13. Well, negative 8 is never going to equal 13, so this is one that's going to be no solution. So let's take a look at the next one. We have 16a and 7a. I'm going to move the smaller one. I'm going to subtract 7a. So 16 take away 7 should give us 9a. Copy the rest. Then get rid of addition and subtraction. I'm going to subtract 21. We have 9a equal to 63. And then last, to get rid of that multiplication, we need to divide. So we have a equal to 63 divided by 9. Well, 9 times 7 is 63. So we got one answer. We got a letter, a variable, equal to a number. So you would write on here, one solution. There's only one answer to this problem. Oops, taking a second here. What's going on? Be patient with me. Well, if we can get to the next slide, we'll solve the next 2 problems. If not, I'll just create another short little video and I'll finish it up there.